find, draw the table, figure out the number of unknowns, figure out which free body diagrams we want to draw all the free body diagrams, find the components of the forces, and then solve for the unknowns. So we're looking at this problem. Remember we did, we already drew all the free body diagrams for this already. So let's just draw them up again. So we had B. A. We drew B and A together. So first we're going to get practice drawing free body diagrams. Then we had the bar. And then in the end we had this whole thing. Okay, let's go around the room. So we were up to Jose. So let's read the problem. Blocks A and B weigh 400 and 200 pounds. So let's do the given first. So how do you want to represent the weight of block A? How about weight W sub A? 400 pounds. Weight of B equals 200 pounds. They rest on a 30-degree inclined plane. It's on the line and are attached to the post, which is held perpendicular to the plane by force of the key. Parallel to the plane, assuming all surfaces are smooth and that the chords are parallel to the plane, determine the value of P. Okay, so the only thing in the words that's not in the picture are the two weights, weight of A and weight of B. And what they want you to do is find P. So Daniel, drawing a free body diagram of B, what do I need to draw on B?
The normal acting on A.
Okay.
Or acting from A.
From A, good, that's the way it's, and let's call it NAB.
Okay.
And then what else do we have on here?
The weight of B.
The weight of B and
Tension.
that tension. So let's call it T1 and T2, does that sound, or you want to call it TB and TA maybe?
Yeah.
Okay, so TB. Okay, Eugene, how about A? What do I have to draw on A?
The normal,
Which one?
both, going up.
Okay, one's going up, and what do you want to call that one?
Normal A,
Good. And?
normal B.
And then normal AB, right? Because it's between A and B. What else do I need to draw on A?
The weight going down.
The weight of A. And?
Question.
One more. The tension at A. Okay, now I do need to put in angles here. So Claire, I'm going to call on you for the angle. I need to have an angle for the weights on both of these. So take a look at this 30 degrees that's drawn here.
Yes.
Right, so where do I draw my 30 degrees? Between the weight and?
Normal.
The weight and the surface?
Well, the surface isn't drawn up here, right?
Oh no, I mean the bottom of the block.
So right here, I see that the 30 degrees lies between the horizontal surface, horizontal and the surface, right? Between the horizontal and the surface. So if the weight is perpendicular to the horizontal surface, what's perpendicular to this?
Center of the block.
The normal, no?
Normal, yeah.
Right? If
Yeah,
two things are perpendicular, they have to be lines, right? So this inclined plane is perpendicular to the normal, and the horizontal line here is perpendicular to the weight. So the angle of 30 degrees goes here. Okay, Sam, what should I put in the free body diagram of the AB now? Putting these two guys together.
Weight AB?
Weight A, correct, and weight B. What else?
Normal on A,
Normal on A.
normal on B.
Well, what happens, because there's a normal between A and B, right? One's going up to B and the other is going down to A. When I put the two blocks together, doesn't it cancel the normals?
Yeah.
They become internal.
TB, TA.
TB, TA. So let's see, we have this. We have this. We have. So when I took free body diagram of A and free body diagram of B and put them together in A and B, what thing got canceled out? The normal in between them. Okay, David, what about this bar?
You got tension A and tension B pointing to the left.
To the left. How come to the left?
The tension goes away from the
That's right.
bar. And then, is that a pin on?
It's a pin.
Alright, so that would be what, PY or OY?
It's O, X, and OY. Okay?
And then you also have a force P
And
up
the
above.
force P.
Pointing at.
Right, and what's the distance? Let's see, this is, I have to put all the distances in now, huh?
Yeah.
Yeah, I drew it so small. I should never have drawn it small. It's too small. Way too small. 'Cause now it's hard for me to see. But we have,
The distance.
6 inches here, and 6 inches here, and this right here is 12 inches. So let's label the free body diagrams. Let's call it, how about free body diagram B? How about free body diagram A? Free body diagram AB? And how about free body diagram bar? How does that sound? Now, did I need to draw all those free body diagrams? No, I just want us to have some practice. We're gonna start to go back through the statics solutions. Javen?
What's going on with the X and Y axis and OX and OY? Is that new axes or?
Oh, so yeah, I didn't draw axes.
Should it be,
So I'm gonna draw one
Okay,
big
you draw
axis
that.
up top
Okay.
to cover everything. And do you wanna slant the axis? I think so, right? Lonnie?
No, that was kind of my question, and then if we were just looking at the bar for some reason, we would just slant it and you.
Yeah, everything, I drew everything slanted. If you wanted, you could have just rotated this whole thing, right? You just say, this is X, and this is Y, and then everything you draw it upright. I just happen to leave it the same way, but my axis is still like this.
So it's just the weights that you have to.
The weight is the only thing, right? All the unknown, that's great. All the unknowns are lying in the axes. The only thing that's lying not on the axis is the weight, but I know the number, so it's not that big of a deal to find the two components. I don't want to break TB, TA, NA, NAB, P, OA, OB. I don't want to break all those into components. It's too much time. So I'm just going to rotate my axis, and then the only thing that's not on the axis are the two weights. Okay, so let's go back to solving the statics problem. Right here is the steps. Find the given and find, identify all the forces and the moments in the system. So let's draw a table. So force, moment, force, moment, magnitude, and direction. So Larson, we're up to you. Will you name all the forces here?
Sure, starting with the bar, or?
Sure, whichever, just everything.
Okay, yeah, there's P, there is TB, TA, OX, OY, WA, BA, NA, NBA.
Am I writing them right? B's on the bottom, no, B's on top.
Yeah,
So it's NA and NAB.
yeah,
Okay, let's go.
I think that's,
Anything else? We got the weights, we got the two normals, we got the two tensions, we have the two, oh, that's kind of nice.
Bless you.
Two T's, two O's, two W's, two N's, and a P. Question mark, question mark, question mark, question mark, done, done, question mark, question mark. So how many unknowns do we have? Larson?
1, 2, 3, 4,
Way
7.
too many.
Yeah, wait. David?
Could we do it kind of like a quiz and instead
Yep.
of like OX and OY have a moment at O?
Well, we still have those unknowns, right? But we don't have to find them. So I'm going in that direction. Good thinking, David. So we have 7 unknowns. Is this a 2D or a 3D problem? How many equations can I get from each free body diagram? 3. Some of the forces in the x equals 0, some of the forces in the y equals 0, some in the moments. So how many free body diagrams do I need? 3. Okay? But I only need 3, is everybody listening? I only need 3 free body diagrams if I need to find all these unknowns, right? These are all the unknowns. If the problem said find all the unknowns, we would definitely have to draw 3 free body diagrams. But what do they want us to find? P. So even though there are 7 unknowns and we would need 3 free body diagrams, we only need to find P. Now, we noticed on the quiz, even though we only wanted to find one thing, we wound up having to use 2 equations at least. So let's take a look at these free body diagrams, and if we wanted to find P, which free body diagram do you know you're gonna have to use? The bar. Why? That's the only free body diagram that has the bar, that has the P in it, right? So what what equation do you think you'd like to do? Some of the moments about? Oh, because notice the block A, block B, and A and B don't have O in it. So there's no way in hell we're going to be able to find the O's unless we do all the equations in the bar. So probably the last equation we're going to do is sum of the moments about O on the bar. So this is free body diagram bar. And then we hope to find what P is. But what other equations do we need to do in order to be able to solve for P using sum of the moments at O? So we're going to have to find TA and TB, right? Okay, so can we find TA with one equation? How? In free body diagram? Yeah. Free body diagram A, we could do sum of the forces in the x equals 0, and what are we going to find? TA. Because we know the weight. The only other force that's in the x is WA. Okay, and then what's the other free body diagram you're going to use? B. Free body diagram B. We could do sum of the forces in the x again, and what are we going to find? TB. How about this? After we find TA in free body diagram A, can we do free body diagram AB? if I have TA from free body diagram A, can I use free body diagram AB? A little more work, but what equation could I use? Sum of the forces in the x equals 0, and it would allow me to find TB. This is how you find all the unknowns on statics problems. Why do we want to know the unknowns? Let's go back to the real world. Why do we want to know what P is as engineers? We don't want A and B to slide down the hill. We don't want the little pin to break at O. In the end, as an engineer, would you need to know all the unknowns? Yes, you would need to know them all. Because you are going to choose what kind of pin to have. So in order to choose the type of pin, you need to know what the values are of OA, X, and OY. You need to know what the reactions are on this pin due to this force and the P. Right? Do you need to know what TA and TB would be as engineers? Yeah, because you have to pick what kind of wire rope. Is it a wire?
Cable.
It says cable. That's probably wire made out of metal. You need to be able to determine what kind of wire rope you want to use so that it doesn't break. Okay? So as engineers, you want to be able to find all the unknowns because you're designing the damn thing. Right? But in this particular problem, they just want you to find P. So you need to be the most efficient. Did anybody see another way to do it in less than 3 unknowns? I don't see it either. No. So why did we pick the bar? That's the only one that had P in it, and they're asking you to find P. Then you determine which equation would you want to do from the free body diagram of the bar. Probably some of the moments about O, so we don't have to find out what O are. But then we need to find out what TA and TB are. So then we went to the other block, to the blocks, to find out what TA and TB are. So do you see what you're doing? Even though we had 7 unknowns in this whole problem, we only needed to find P. But in the end, how many free body diagrams did we use anyway? 3. So 7 unknowns leads to needing 7 equations, which leads to we need 3 free body diagrams. In the end, we used 3 anyway. And we just picked equations from each of the free body diagrams that would be most efficient. Jabin.
How did you know from 7 equations that you need 3 free body diagrams, or is
Oh,
this the most?
because remember on a 2D problem, you have a maximum of 3 equations. Right? On a 2D problem, we have some of the forces in the X, some forces in the Y, and some of the moments. So for a 2D problem, I have 3 equations possible. So if I have 7 unknowns and I need 7 equations, I divide 7 by 3, and it's over 2, so I need 3 equations, 3 bodies. So I need 3 equations from one body, 3 equations from another body, and then 1 more equation from a third body. Good? Uriah?
So it seems like it's more beneficial to draw the free body diagrams first.
That's the question I was going to ask you next. Do you like drawing the free body diagrams first?
Yeah.
I mean, I kind of like it because I can separate everything. It's kind of like a puzzle. For me, I like drawing them first. But you don't have to draw them first. You could follow this order and determine how many you need and then draw them. Okay? But what is cool about this problem is we knew we definitely would need to draw a free body diagram of the bar because that's the only place P is. Right? And then we would have to find something with TA and TB, so I would need 2 other free body diagrams. Rachel, you had a question?
Could you do it in 2
Okay, let's try it.
The free body diagram with the, of everything.
Ooh,
And
yeah.
then you would do some of the
Yes,
focus
excellent.
or
Okay,
some of the moments.
so let's do that.
You can
Good job.
find NA.
Okay, so which one's on top? Is it B?
Yeah.
Excellent. Okay, so give me distances, 6 inches, 6 inches, 12
Yeah.
to P, right?
Yeah.
And then you just have NA in the middle.
So P,
And
this is great. And we have OX and OY, and we have weight A, weight B, and they're both 30 degrees. And then NA, right?
yeah, so then when you
Okay.
do some of the moments around O, you just need to find NA.
Okay, so, do you want to still do this equation?
Yeah,
Okay, so you want to do this free body diagram for, well, that's the last one, right?
right.
Okay, so,
Free body diagram, everything.
okay, so Rachel, tell me what you want to do?
Do some of the moments around O. And then you would need to find,
Do they give you the distances of the, how wide?
Oh, do they?
I don't think they do.
Oh,
They don't tell you the width of the bar, of the blocks.
never mind then.
Okay, but you were saying find the moment, do the sum of the moments about here, it would include P.
Right,
It
and
would
then you have the
include-
weights, so you don't have to worry about that. But you have to split them up into components, so it'd be kind of a lot of work. But then,
And then you would
need
need to
find
know this
NA,
distance
and
too, right?
you can use free body diagram AB to find.
But then you have two unknowns there.
So when you do some of the
no,
moments
you do
here,
some
you-
of the forces in the Y for free body diagram AB to find NA.
But you have NAB and NA.
No, she's putting A in. All right, so let's look at this. So if we did some of the moments here, we have this unknown and this unknown, right? Everybody realizes we couldn't do this, right? Because they don't give us distances of the block, the dimensions of the block. But if we did some of the moments about this, we would have P and NA, that would be two unknowns. And then you're going to the block, the one with 2. Then we would do some of the forces in the Y would give you an equation of NA and WA and WB.
Can we do?
Yeah,
That's okay.
you'd have two equations, two unknowns, great.
Well, I can-
Yeah, that's great.